Well, this is intermediate lesson 6, graphical representations. Coordinate plane, Cartesian coordinate plane, has two axes. Horizontal axis typically is called the x-axis. The vertical axis typically is called the y-axis. Where those two meet each other, that's called the origin. Makes up 4 quadrants. Top right is quadrant 1, top left is quadrant 2, bottom left is quadrant 3, and bottom right is quadrant 4. If you go to the right, the x values are positive. If you go to the left, the x values are negative. If you go up, the y values are positive. If you go down, the y values are negative. All important things. Also, this coordinate plane is often used for navigation. Typically, the positive y-axis is north, negative y-axis is south, and then east and west. Yeah, that's good. Well done. Let's look at this example. Relative to the origin, point P is located 4 units east and 5 units north. So let's plot that. So we get a coordinate plane. So north, south, east, west. P is located 4 units east and 5 units north. So 1, 2, 3, 4 east, 1, 2, 3, 4, 5 north, point P. Q is located 4 units west and 5 units north. 1, 2, 3, 4, and then up 5 is Q. And then it says R is located 4 units west and 2 units south. So 4 and then down 2. Just going to put us here. That is R. D is located 3 units east, 4 units south. So I would put us here. That's how you plot the points. Example 2, plot the ordered pair negative 3, 8. We're going to draw a coordinate plane. First number tells you to go left or right. It says go left 3. Second number tells you how far up or down to go. It says to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's about right here is negative 3, 8. Number lines, well, that's just a fancy schmancy math thing for a line with numbers on it. Here's a couple examples. How far apart are these 2 points? From negative 4 to 2. 1, 2, 3, 4, 5, they are 6 apart. You could say the distance from those 2 points is 6. Down here, the distance from 1 to 4 is 3. You can just count the spaces. It's that simple. Well, it's not simple when you're in a coordinate plane. Well, potentially not as simple. If you're fortunate enough that your segment you're trying to find the length of is horizontal or vertical, then it's pretty simple. This horizontal segment is 2 in length, and this vertical segment is 4 in length. Where it gets tricky is if you're trying to find the distance of a segment that's not horizontal or vertical. You can just count spaces because there's no grid to count in that direction. That is what the midpoint of a line segment is for. To find the midpoint, which is a capital M is used to represent that, you are going to take the sum of the x values and divide it by 2, followed by the sum of the y values and divide it by 2. You've probably seen more often x1 plus x2 divided by 2, y1 plus y2 divided by 2. Once again, Greek symbol here means to sum, add up all the x's. Here, add up all the y's, so it's just going to be 2 in each case. Show you an example. Find the midpoint between these two ordered pairs. So if we sum the x values, and then sum the y values, divide each of those by 2, our x values are negative 5 and 11. So if we add those together, we're going to get 6. We add the y values, 8 plus 34 is 42. It's going to give us the ordered pair 321. This is the midpoint, halfway point between those two ordered pairs. Next example is a little more complicated, a little more thought. One endpoint of a circle diameter is located at 3, 1. If the center of the circle is 15, 10, find the other endpoint. Well, there's an easy way to do this and there's a hard way. Let's do the easy way. It says the center is at 15, 10. I'm just going to say this is 15, and I'm going to say this is 10. One endpoint of the circle diameter is 13, 1. So let's say that this here is 13, 1. So that means that we have the circle, make it smaller, something like this, not drawn to scale. And we have this diameter that goes like this. And we need to find the coordinates of this point. Well, here's what makes this easy. If you look at this as two separate number lines, look at the x values. From 13 to 15, you go 2 to the right. So to get from 15 to this, you're going to also go 2 to the right. So that's going to be at 17. If we do a similar thing to get from 1 to 10, the y values, you go up 9. So to get to 10 to this up here, you have to go up 9 more. That's going to be 19. So it's the ordered pair 17, 19. There's an algebraic way to do it as well, but it's not near as easy as that is. Looking at your answer to make sure it's correct, is 15 the middle between 13 and 17? Certainly is. Is 10 halfway between 1 and 19? Certainly is. So we know that our answer is correct, the order pair 17, 19. Inequalities on number lines. Write an inequality, or write the equation of the linear inequality that is graphed below. So here's how this works. We are going to use x as our variable, and when we look at our starting point, it's starting at negative 2. We want all the numbers to the right of it. But we want all the numbers that x are greater than negative 2. Since this is an open circle, we're just going to have a greater than. If it was a closed-in circle, it would be equal to. But it's not closed in. So this is x is greater than negative 2, which is red. X is greater than negative 2. Number 2, write the equation. Shouldn't really say equation. It should be inequality. Of a linear inequality that's graphed below. Here we're starting at 2. And it's everything less than that. So x is less than 2. It's a closed circle, so it's less than or equal to. So any number that's less than or equal to 2 would follow this thing here that's darkened in. Number 3, we have a starting point. We have an ending point. The arrow does not go on forever. So x is in the middle. X is less than or equal to 1. That's this part. Also, x is greater than negative 3. Now, it's confusing to some people. It's x is greater than negative 3. If you look at how this is written, it's from left to right, it says negative 3 is less than x, which is true. But if you read it with the x first, x is greater than negative 3. Get it from left to right, negative 3 is less than x. Both those things are consistent with each other. So different forms of lines. Slope-intercept form. Let's talk about that. Slope-intercept form is y equals mx plus b, where b is the y-intercept and m is the slope. Another form we should discuss is point slope form, which is extremely useful if you have a point and you have a slope. That's why it's called point slope form. And it is written like this. It is actually just the slope formula. If you don't understand what I mean by that, come back and ask me and I will show you. It will blow your mind, quite frankly. So to use this, you put the slope in your m and you replace x1 and y with an ordered pair. So question 1. Find the slope of a line containing these 2 points. Well, to find the slope, it's easy. We use the slope formula, which I haven't mentioned yet, which is lowercase m equals delta y over delta x. What does delta mean? It means subtract. So you've probably seen this more likely like this. Lowercase m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Make sure your m is lowercase. So I prefer to use delta y over delta x. Delta means subtract. This takes less writing. Our y values are 2 minus 22. Our x values are 3 minus 8. Going to give us negative 20 over negative 5. Gives us a slope of 4. This line has a slope of 4. Number 2, find the slope of a line given by this equation. Well, if we put it in slope-intercept form, we'll know what the slope is. It'll be obvious. Then we're going to subtract 6x from both sides, and then divide both sides by 12. Negative 6 over 12 reduces to negative 1/2. And the y-intercept is 13/12, but you don't care because it just asks for the slope. Slope's negative 1/2. I'm getting close to being finished. It's exciting. Number 3, the points given are on a line. What is the y-intercept of this line? Well, depending on the problem, this could be complicated, but it's not for this. The y-axis, any place on the y-axis, the x value has to be 0. The x value tells you how far to go left or right. The y-intercept is 7. It tells you that by telling you that the x value is 0. Done. How to graph a line? Well, it's real easy. You graph the y-intercept and use the slope to find other points. Y equals x is really y equals 1 over 1 times x plus 0. Y-intercept is 0. It's the origin. Slope is 1 over 1. So if we go up 1 to the right 1, or down 1 to the left 1, that's our line. Done. Number 2, graph y equals 2x, which is the same as y equals 2x plus 0. Graph the y-intercept first. This one just happens to be 0 again. The slope will up to into the right one, or down to into the left one. Missed. There's your line. Alright, last problem. The line of best fit for y equals f of x for the ordered pairs given is best represented by which of the following graphs? Well, let's see. What I would do is just find the slope. If all these points, well, it's a line of best fit, so all these points might not be on this. tell you what, I'm just going to plot these points on a bigger graph and see which one fits it the best. -4, -12 would be something like this. +1, 3 might be something like this. 2, 6 might be something like this. 3, 9 might be something like this. 4, 12, something like this. So can't be C, that has a negative slope. Can't be E, that has a negative slope. D can't be because it goes to the right faster than it goes up. And ours goes up faster than it goes to the right. B looks like it goes to the right just as fast as it goes up. And A goes up faster than it goes to the right. So I'm going to say A is the answer. Please do exercise set 6. You're welcome for this not taking forever like the previous two have.